The graph shows how the maximum kinetic energy EK max of photoelectrons emitted from a metal surface varies with the frequency f of the incident radiation. P is the intercept on the f-axis, which we see over here, and then Q is the intercept on the kinetic energy axis. Which graph shows the variation of EK max with frequency for a metal with a greater work function? Alright, so let's think about Einstein's photoelectric effect equation. HF is phi plus Ke max. So we want to think about how a greater work function affects this graph. Let's get this equation here in the form of y is equal to mx plus c. So we want our y value to be the kinetic energy, the max Ke, and we want our x value to be frequency. So if we rearrange this equation to make Ke max the subject, so that is our y, and then that will be equal to hf minus phi. So this is mx plus c, frequency is our x value which we want, the gradient is Planck's constant, and the y-intercept is the negative of the work function. So if we're increasing our work function, we're making phi bigger, that makes our y-intercept more negative. So then the graph that we have should sink down lower. The y-intercept should become more negative, which corresponds to the work function getting bigger. So which of these graphs has that? So A, the y-intercept is getting higher, so it's not that. B could work, C could work, and D has the same y-intercept as before, so it can't be D. So it's either going to be B or C. Which one would it be? Let's go back to our equation. Let's think about the gradient of our graph. So the gradient of our graph is Planck's constant. Planck's constant, as the name suggests, is a constant, so the gradient of our graph should be unchanged. So if we are to move our line downwards, so the y-intercept gets more negative, it shifts beneath Q, that will also change our x-intercept. If we move the whole line downwards, so it's like over here, then the x-intercept will move towards the right as well. So looking at B and C, the answer will therefore be C, because the x-intercept has shifted towards the right. It can't be B because B has the same x-intercept as before. Our previous line went through Q and P. Our new line is going just beneath Q and through P, therefore has a steeper gradient than the line that goes through Q and P. Our gradient has to stay the same. So it must be C. What does the x-intercept represent? The x-intercept represents the threshold frequency. The x-intercept is the lowest frequency that can cause the emission of electrons from the metal surface. If you increase the work function, the photons need to have a higher energy to liberate electrons from the metal surface, and therefore the threshold frequency should increase, the x-intercept should increase. So that also agrees with option C.